Hello everybody, welcome back to the Stray Basilisk Coding from Scratch stream. I'm Jason. I think this is episode 13, so hopefully nothing goes too terribly wrong. As usual, we'll give a few minutes for people to turn up, and then I'll kind of explain exactly what we're doing, and we'll get stuck into the code. So today's topic was voted for on our Twitter. What we normally do every Thursday is that we post a poll for whatever topic to cover. So the options this time were Peggle clone. I keep adding this to the list because I really want to make it. So far it hasn't been super popular. If it doesn't get picked up some week soon, then maybe I'll just drop it off of here. We also have a fluid or sand simulation, which is what's on this time, and then something else, a kind of new appearance here is a Discord bot. I think there's some really cool, interesting stuff we could do with like a Steamhounds themed Discord bot for our server. Also, making Discord bots for whatever reason seems to be a super common thing for people to do on Twitch on these coding streams for whatever reason. So maybe that's something we'll do in the future. But for now, the winner was fluid and sand simulation. I believe that was suggested by Fluffy. Yeah, and it's kind of more or less a clear landslide victory here. So, what is it? What is one of these? Excuse me. What is one of these water and sand simulations? Basically, it's this kind of thing. If you've ever seen these, this is an old school thing from back in the day. There was a whole load of games based around this concept, and they're normally kind of pixely, which is kind of necessary because there's quite a lot of simulation stuff going on here. But you have a relatively low resolution screen. You know, this was popular back in the day on the old machines. I want to say from the 80s even. Maybe 90s, I'm not sure exactly when the first one originated, but there are a whole load of kind of clones and copycat games in this style. And normally, basically, it's more like a toy than a full-fledged game, and what you can do is you can spawn bits of water and sand, and they'll kind of fall down, and, you know, sand will pile up or like form these kind of shapes, and water will kind of spread around and slosh around in a somewhat natural-seeming way. And it looks really cool, it's really fun to play with. There's loads of other stuff you can add in, like I've seen people add, you know, like gasoline and fire and all sorts of crazy elemental stuff on top of this, but the basis always seems to be water and sand. And actually under the hood, in terms of making this kind of cool visual behavior happen, it can be relatively simple. Like, relatively speaking, in terms of a physics simulation, this is a pretty simple thing to do. And it's kind of a grid-based cellular thing. Yeah, which I suppose we can kind of get into now, exactly how this works. So, you know what, first of all, I think the first step, before I start explaining how the physics works, is to maybe think about how we just get this basic stuff drawn onto the screen. So under the hood, we're going to kind of have a grid which knows what's existing in every little pixel position, right? So this is solid ground, this is sand, this is water, this is, I guess, air, and then those are drawn in different colors. And even getting that done can sometimes be, you know, we need to figure out an approach to this. Hey, Meowtello, thanks for the follow. Thanks very much. And hope you enjoy the stream. Yeah, so let's start thinking about how we create this grid and how we even draw that thing. So it makes sense that we probably want a predefined like width and height for this. These may not translate directly to pixels. We may like scale it up so it's a bit more visible, but the underlying sort of world this is happening in can have a certain width and height. We can tweak this, but for now I'm just going to say 256 pixels seems reasonable. Depending on how fast this runs, this may actually start to become an issue, right? So we'll figure out how quickly this runs, and we'll size this to make sure it runs at a reasonable rate. And then, at the very least, what we want is some kind of grid or array which represents this entire deal. I think I'm going to use an array of bytes because, you know, normally in these streams, like, efficiency isn't really an issue, but I feel like at this point, to make something like this work and have a reasonable resolution, we may need to think a little bit about efficiency and not using like full-fledged classes for every little tile and every object here. If we can do that with just a little byte which holds this information, that seems to me like a reasonable way to go about this. So I'm probably going to have a byte for each cell, and I'm just going to call this world for now. And then I think also what I want to do is kind of have some constants which represent, there's 256 possible values of a byte, but we probably only need 3 or 4 different types of thing to exist in this world. We'll need air, we'll need ground, we'll need sand and water probably. So I'm just going to give each one of those their own kind of special value. So let's call that air, which makes sense to me for that to be 0. Maybe not ground, maybe just solid, or like rock, let's call it. Sand. Okay. So I'm using processing to do this, by the way. So processing's a really nice Java-based framework for doing like simple graphical rendering stuff. It comes with this own nice little editor. I say nice little editor. It's good as a simple thing. You can literally just download and run it. And if you're getting started with programming, this I think is a pretty good starting point. As you get to bigger and bigger projects, it becomes kind of awkward to work with. So this is really good for these evening projects or small little self-contained things. So I like to use it for these streams. But the way that processing works is it define a set function called setup, which it calls right at the start to kind of initialize everything. Oh, thank you. So yeah, let's try and find an example of this. So yeah, this is kind of example. So actually, I've got another really good example I can show. Normally, this is a kind of toy, right? So people create these games where you can. They're almost like a paint program, where you can have like a little palette of different things, and you can drop them down. You can place water and gasoline. Hey, Fluffy, aka Cake, how's it going? We're doing your thing, right? We're doing this water simulation. That's what we're doing today. Yeah, so normally these are kind of like little building toys. You have different materials you can place down. They interact in different ways. Yeah, this is what I remember the real original ones kind of looking like. Yeah, it's kind of a nostalgic thing. There's not really a point to it. It's more about just kind of playing around. But what somebody's done more recently, taking advantage of this, is there's a game called Noita, which has some really cool effects around this. In fact, let me just pull up the trailer here. Yeah, I don't know if you got the audio for that trailer, by the way, but it's pretty epic, and you can do some cool things with these materials. Yeah, it does remind me of Worms as well, like that style of taking big chunks out of the rock. Yeah, it's Worms is a pretty good comparison there. It's kind of like a pixely physics thing. So people can make games around this whole concept, but originally I think it was mostly just little toy like things like this. And this is kind of what I'm going to try and make today, because we only have a couple of hours, and I kind of want to get this done, start to finish, like during this one stream. So processing, we'll call this once at the start of the program. So this is where we do our initialization stuff. It's where we create the window. So we first need to call this size function. I could just put this width and height in, but I think I maybe want to scale that up. I'd like to create a little scale factor here. Maybe 4, yeah, that probably makes sense. Okay. then we kind of want to define our world, right? So how big is it going to be? It's going to be width by height. So in this case, 256 by 256. So we need to create enough space here for that entire kind of 2D grid, if you like. And the way we're going to do this is something super, super common. So normally you think of this grid. Oh, I'm not drawing a line. Normally you'd think of a grid as like a 2D. Oh wow, that's supposed to be rectangular. Normally you'd think of this as like a 2D thing like this. But very often when you actually... Yeah, that's right. You'll have like a little drawing tool. You'll be able to place kind of solid rock and sand and water, and then it will like fall and roll around, and the water will flow around, and you'll be able to like make little sand castles and yeah, things like that. Yeah, so normally when you have this map, you know, this might be sand. You might have a little pile of sand, and then some more sand like this, and then a little bit of water sitting in it. You know, this is a really low resolution thing, but it'd be much bigger. But typically when we create this in the memory of our computer, we'd actually just store it in a big, like, long line, right? So even though it's like 3 by 3, the RAM in your computer is more or less just a big, endless, like, strip of memory. So what you typically do is like just kind of flatten this out so that the top section here is like the first 3 bits, the second row is like the second 3 bits, and so on like that. That's kind of more typically. If you have 2 kinds of sand, okay, definitely ideas for what stuff we want in the simulation. It's definitely stuff we can look into. I think the main thing in the simplest version of this is that things just don't... Oh, okay, yeah. So I thought about having... What we'll probably want is... I think of air just representing like an empty space. Then sand. And then water. Oh. Wow, ignore my terrible writing. And then what you normally see in these things is like this kind of stone, and you can just draw this. Yeah, it's nice to be able to have stuff kind of floating in the air, so I'll maybe call it stone for now, but something that you can draw and it will just float. So then you can make little channels for things to flow around in. But yeah, exactly. You need something that's like solid, otherwise the whole world just falls through the bottom of the screen and then you're having a bad day. Yeah, so I'll call it stone. But it's going to be like magical levitating stone which doesn't fall anywhere. Okay, so we've got this kind of grid for our world. But bearing in mind that we want to think of it as like a 2D thing with like coordinates, right? So, you know, this is like 0, 1, 2, like along the X, and then 0, 1, 2, like along the Y. But the thing's actually stored in a big line, which is kind of more like 0, 1, 2, 3, 4, 5, 6. So we need to be able to take our kind of coordinate, like let's say we want this, which is like 2, 1, and figure out, hey, whereabouts in this thing is it? No, it's actually here, right? And the way we think about that is, so what was it? X equals 2, Y equals 1 for this cell, but the actual position is like number 5 because of how this is laid out. And the way we can like calculate between these is to say X plus Y times width is how we kind of calculate that. Why is this? It's because every time Y goes up, you're jumping down to a new row, so you're kind of stepping along by like 3 in this. And every time X goes up, you're just moving along like 1 slot. So that's kind of what that little formula represents. So if you're ever dealing with like a 2D grid in coding, this is like a super common way to do stuff. Seems good. So my knowledge of Twitch emojis is not super great, so I will take that at face value and assume it means what it says when I hover over it. So what I'm going to do is create a little function to convert between like that 2D coordinate into the actual world array here, if that makes sense, because that's something I'm going to want to do very often. And that's what that is there. Seems good, yep. So now let's put some stuff in our world, right? So we're going to want to be able to draw this world. Let's say we want, so we've got our whole world, maybe we want, yeah, cool, seems good means seems good, okay. So I think it makes sense to give this like a floor, so we'll fill it with a rock, like at the bottom. Maybe that's a good like starting point for like our blank canvas kind of thing. Did I call it rock? Yes, I did. So let's like make a line of a rock at the bottom. So how would we do that? So we want to go all the way across the bottom. So starting at x is 0, up until the width, and then increasing the x, and then I just want to say, so the y is going to be height minus 1. So the bottom row of this thing, by the way, because we start counting at 0, even though the height of this is, say, 3, the bottom row is actually row 2 because it starts at 0. So the bottom row is height minus 1. So that indicates the bottom row. So then we can use this little helper function to convert that coordinate into the actual position in this big long bit of memory, which is actually our world, if you like. And then I'm just going to set it equal to rock. So in code, you know, that's how we'd fill in some of these pixels. We still need to draw this thing. So the way we do that is processing will call this draw function for us. So every time there's a frame, it will kind of call this over and over. So this is where we do all of our kind of update and draw stuff. What we really need to do in here is actually draw the grid, or draw the world. So there's a couple of ways we can do this. Okay, so we've got our actual screen, right? And then we've got our world, and we wanted this to be scaled up, right? So that one little section in our world is actually not just 1 pixel, but in this case we created a scale factor of 4. So one way to do that is to just manually fill in like 4 pixels, you know, to fill in like 4 pixels for every kind of block in our world, which is kind of a pain to do. Another way is to, which I think I'm going to go with, is to create an image kind of off screen, if you like, to draw a world in there like 1 to 1, so 1 pixel for everything in the world, and then kind of ask our fancy graphics card to just draw this like stretched over the entire screen, and then that will handle for us like all the scaling. So in order to kind of do all that drawing sort of off screen, if you like, the way we do that is we need to use this off-screen graphics thing. So this is something we also did in the previous stream with all the fireflies, in fact. So we can create this little graphics object, which is kind of like a little texture. We can read and write the pixels of that as much as we like, and then we can just draw it onto the screen itself. So I think what I'll do there is let's call it world GFX maybe. And then we'll create it. good. And then when we draw the world, the way we do that is we say, hey, I'm going to start messing around with the pixels of this thing, so I have to call this begin draw function, which says make sure those pixels are like loaded and available for me to fiddle around with. And then at the end, I'm going to say end draw, and then what I'm going to do is actually draw that thing, which wouldn't be visible at this point, onto our actual screen. And we can do that is just with use the scale factor and then draw the image. I believe that will work. How do we actually draw this thing? So what I need to do is go over our entire world and start filling in the pixels in this image based on what's in the world at that point, if you like. So let's go over every single x and y coordinate we have. So now we have these kind of nested loops like this. So this will go y is 0, y is 1, y is 2, all the way up to y is the last row of our image. And then similarly for x, it's going to go across each row. And then I think what I want to do is look at what's in our world at that point, and I'm going to assign a different color based on each of these. So actually, let's say so we're calling this to translate from our x and y into our actual position in this big array in the memory that holds our whole world. And then we pull out that thing, and then based on what's in there, it's a switch statement. We can do this. So case, if it's air, then our color is going to be, I think this is the way I do this, so let's say black. Kind of writing this in a condensed form. If it's stone, then let's give it like a mid-gray color. Did I call it stone? Rock. There we go. If it's water, then I guess it's got to be blue. And if it's sand, then oh, my knowledge of colors is not great. How do we make a yellow? So yellow is red and green together with no blue. It's like a bright yellow. So let's give it loads of red and green, but no blue. Nope, wrong thing. So we want red and green, no blue there. By the way, if anything doesn't make sense or people have questions or suggestions, then feel free to interrupt in the chat at any point. So what are we doing? So we are looking up, you know, like what's here in the world at this particular location. And then we're setting a color to different colors based on whether it's air, rock, water, or sand. And then what we want to do is probably pull out the pixel, which actually has the same coordinate, so I'm going to reuse this. Okay, what happens if what's in there doesn't match what we expect? Then let's use red, because it means something's gone weirdly wrong, because we shouldn't have anything else in our world at that point. So interestingly, our little world with all of these things is using an array very similar to how the actual processing stores the pixels of an image. So you can see this thing where we have a 2D thing like an image or a world represented by a long strip of things is so common that we've already got two examples of the same thing going on here. So we are going over every pixel, looking at what's in the world, and then coloring based on that. No worries, Quaff. Thanks for dropping in, and thanks for the suggestion of the topic. Cool. Do you have to go outside again? Try and keep dry. Okay, I've written a lot of code here. I've probably messed something up, so let's see if this works. Ooh, so I just got an interesting error. Okay, so there's a slightly annoying limitation in processing, or in this version of processing, where I'm not allowed to actually use variables in here. I have to like kind of hard code what's in there, which is really annoying, to be honest. Will it let me just do this? Wow, I literally need to like manually type this in. That's kind of weird. I think what it's doing is it's normally the code would just run and it would do these calculations and then it would pass them through to size and it would all be good. But I believe what it does is it actually like scans your code specifically looking for this line for some obscure technical reason. So it's an annoying limitation. Maybe there's a way around it. Any processing gurus, let me know, because it's kind of terrible that you have to do this, but I'll give them a pass because I like processing otherwise. Oop. So we got an error. I think that's because if I'm going to play around with the pixels, I think I have to do, okay, yeah, maybe load pixels. Why is this? It's because probably the actual image is stored on the graphics card somewhere, so the pixels may not be like readily available, so it has to make sure they're in the CPU and not just on the graphics card, if that makes sense. Update pixels, there we go. I wonder if I even need to call begin and end draw if I'm using these pixels like this. Let's see. Oh, cool, this appears to be working. May not be able to see, but there is in fact a little line at the very bottom here. So first of all, we can make this bit of ground thicker. So we can also see that it's kind of blurred. That's because it's probably scaled up this image by that factor of 4 and done it with like smoothing enabled, which we probably don't want to happen. So let's see if there's a way to make sure that doesn't happen. So it's probably called something to do with filtering. Let's go to Google. Processing. Like somebody's had that same question. Yeah, they're trying to get around this blurriness issue. No smooth. Interesting. Interesting. Okay. It's not something I've had to do before with processing, so might take some fiddling. Probably not a huge deal. It maybe doesn't matter if stuff is smooth. Oh. That did not do what I wanted. Already on a tangent, just trying to draw a grid of pixels. Maybe I can call it on this thing specifically. Nope, still doesn't like that. Yeah, this is what I want to do, but how do I set this mode? Okay, we have done it. It looks like we had to do some hacky internal thing, but we now have a nice crisp pixel, pseudo pixel going on here. Gives us a nice basis. Definitely comment this. Okay, so we've got one line of rock at the bottom. I feel like I want probably more of those. So let's actually start from minus 10, let's say, to height. Then let's do a line for several rows at once, like this. We should have some chunkier ground at the bottom. Nice. Looks pretty good to me there. Let's put a little blob of sand that we can play around with. Later on I want to be able to do this with the mouse, but for now, let's just make a little block, and hopefully we'll see it fall down once we implement some of the physics. So let's say y equals a little 10 by 10-ish block. Okay, we've now spawned in a little block of sand, so now the next thing to do is to actually apply some physics to this. So that's the big question, right? How does all this physicsy stuff work? And thankfully I have found a helpful article which explains some stuff about how we might be able to do this. So let's have a quick look through this. Yeah, this diagram I think is going to kind of summarize what we need. Yeah, it's this kind of stuff, right? So if there's an empty space below it, we just move it down. If there's an empty space kind of to the sides, then either it's always going to go, we say it always goes left if it can, otherwise it goes right, or maybe you do a little random flip-floppy thing here. And these rules, like super simple as they are, we'll kind of do what we want. Though there are some cases we need to consider which will cause stuff to get a bit weird. So let's do it the most, I suppose what we'd call the naive approach first, and then we'll fill in some of the corrections that need to be made to like stop this from acting weirdly. But in principle, this is what's going to happen. Like maybe people in the chat can anticipate already why this might not be quite enough. And there's a couple of possible ways around that which we will check out. But the basics is that we kind of want to update the world. And in principle, we just want to go through every pixel, consider everything, and then look at its kind of immediate environment and say, if there's a space below me, I'm just going to move myself down. If there's a space to the diagonal sides, then I'm going to move. For now, let's just say, if this space is open, I'll move that bottom left. If this space is open, I'll move bottom right. So this will kind of have priority if they're both open. Yeah, so let's do that. So again, we want to loop over everything. People who have already spotted why there's some issues with this, throw them in the chat if you like, but I'm aware that this is not quite right and we can fix some of that. So right, so we kind of want to know if a tile is empty. Right, so there are a couple of cases we definitely need to consider, right? So if we're zoomed right in here and we've got a bit of sand on the ground, it's going to still want to check whether there's empty space below it, but that's like off the edge of the world. So we kind of want to say if you're looking at a tile that's kind of outside of the window, then it's always considered like not to be empty. You can't fall down into there. I mean, that's one way to do it. We could go the other way and have just stuff fall through into nothingness, but this seems like a sensible approach. So I think we can say if basically stuff's not going to be able to fall outside of the screen. So if the x is like less than 0, or the x is off the side to the right, or the y is less than 0, so it's kind of off the top of the screen, or the y is kind of outside of the bounds, then we're going to return false. Like a tile's not free if it's off screen. Otherwise, we're going to need to actually check what's in that tile, and basically if there's air in that tile, then we'll consider it to be free for us. So it's free if the world at that coordinate is air, then it's free. Okay. So we need to figure out what's... We're going to get, yeah, so up here we're going through every little pixel in turn and checking what's there. If it's air, then we don't need to do anything, right? So if there's air, or in fact if it's rock, because the rock's not going to move either, then we're just going to kind of skip this thing and not do anything with it. Otherwise it's something which can fall. So I'm going to say if tile free at x and then y plus 1, meaning the tile below us. As y increases, we're going like down the screen. So if the tile's free below us, then we want to set this to be equal to... We're basically moving ourselves, right? And what does moving ourselves mean? It means... In fact, let's make a little function for this, because it's going to be a common thing to do. So void move uh, from right, so all we're saying is that right, so we're taking whatever's in our current position and copying it in this line into our next position, and then we need to make sure that we leave some empty space behind us, right? Because without this line, it would just be like duplicating itself, cloning itself. But here, we kind of copy ourselves to the neighboring tile, and then we fill in the old space with air, which makes sense to me. So if the tile below us is free, then so we're going to move from x, y to x, y plus 1. Cool. I called it tile is free, I think. Okay. Otherwise, we're going to try and go like down and left. And then the last thing we're going to try and do is move down and right, which is kind of like this. Okay, this is going to have some issues, but this will be a good starting point for us. So what we're going to do, we're going to go over everything in the world. We're going to check what's there. If it's air or rock, it's just going to stay where it is. Otherwise, it means it's something which can move, so it's either sand or water right now. If the tile directly below is free, then we're going to move ourselves down there. The tile to the bottom left is free, we're going to move ourselves down there. And then the final thing, if it's down and right, kind of the lowest priority, we'll move ourselves down there. So this should do something, and we'll see some jankiness, probably a few kinds of jankiness, which we can try and figure out. Or it will crash because I got something totally wrong. Okay, what happened? Something kind of fell, but also something kind of weird happened. I tell you what I will do is actually really slow down the frame rate so we can take a look at what the heck has happened there. So let's go to 1 frame per second and try and figure this out. Okay, straight away some sounds appeared immediately on the bottom, and now it's piling up, but it's not piling up symmetrically. So, 2 issues, right? The one is it's not piling up symmetrically, which kind of makes sense because we're doing this where we'll always go down and left if that space is free, and only if it's not free we'll go down and right. So one way is to, around this, is to do a kind of coin toss, and then we'll check either right first or left first. So let's do that. So yeah, so it's not so kind of biased. So kind of a 50-50 chance there. We could get fancy and compress this code, but I think I'm okay with just saying a little bit of copy pasting check left first, we use the current logic like that. Otherwise, we're going to kind of just do them in the opposite order. Normally I would find a way to factor this out, but honestly this core code is not going to change much beyond this, so I'm kind of okay with it being a little repetitive, because it's, yeah, all things told, it's not going to be a huge amount of duplicated code. Okay, plus it's just kind of clearer. Down left, down right. So, okay, let's see if that fixes the sort of uneven sand pile problem. Kind of. It definitely doesn't look exactly the same. There's maybe still some issues. Whoa! Hello, Malieve. How's it going? Hello, everybody. What you've just walked in on is... Thanks, Malieve. So what you've walked in on is us making this little falling sand simulation. So this is an old thing, I want to say from the 80s, where you'd create these, like, almost like a little playground toy thing, where you could make sand and water and stone, and you could kind of draw this and have it fall down. Yeah. Hey, Elemento, how's it going? So you've reached us at a point where this is what we have. So something's going on here, right? Like we have a little screen, we have a little pile of sand here, so it may all look promising, but there are a couple of subtleties. So first of all, I should probably recount kind of how this works. The basic principle is we define this little like grid world, and this blog article, by the way, is a kind of good introduction to how this stuff works. And then what happens is, say you've got a little speck of water here. Every frame, it's just going to check if the tile beneath me is free. I'm just going to move myself down. Otherwise, I'm going to try and either go like down left or down right. Yeah, so in this situation, it will go down either kind of direction. So we've got a bit of code here which does that. So if the tile below me is free, it goes down. Otherwise, we're adding a bit of fanciness where, so in this example, if bottom left is free, it will always go like down and left, and it will only go down and right as like a last resort, which is more or less fine, but it results in a kind of bias, right? So the sand will always pile up in like an asymmetrical way. So we've made that a little bit fancier by effectively tossing a coin, and then we'll either check right or left first based on that kind of random, if you want to say coin toss, so that it's a bit more sort of symmetrical and sort of balanced and stuff. So we kind of got that working, and we can watch this play out like frame by frame. But there's something weird going on, which is the sand is kind of teleporting down to the ground. And that's, again, an implication of following these like simple rules. And it's kind of subtle, but what's happening is something like this. So when we're doing this processing, let me draw another little... Actually, let me delete all of this and draw something again. Yeah, it's like magical. We'll just call it magic sand and call it a day. I don't need to fix this. Awesome. Yeah, so we have this kind of grid world. Go. Problem solved. Just creative narrative framing. That's the solution to everything. So yeah, so the issue is, let's say we've got a bit of water here. So the way this works is we're kind of checking each cell in turn and then applying that little logic where stuff can fall. So we get to this guy, we go, oh look, this tile below me is free, so I'm going to move myself down there. But then we continue like rolling through the world, and then we come here and we go, oh, water. Can I move down? Yes, I can. So this thing like leapfrogs all the way down in one frame. And what we really want to do is say, if you've already moved, then you're now fixed, right? You've been updated already. This water is like locked in now. So when we come to check this tile again, we go, hey, we've already like dealt with this, so let's not mess around with that again. So it's only like, you know, we do the whole rest of the thing, and then we'd come around like for the totally next frame, and then eventually we'd get to this thing and it would slowly work its way down like frame by frame. So that's kind of what we need to do. There are a few ways around this. A very simple one is, yeah, right? So effectively what we want to do is remember that we've already moved it. There are loads of ways to do this. I kind of want to get somewhat old school and fancy. So right now, the way that we're storing what's in each of these things is computers have memory, and this isn't actually water, right? It's actually just a number. So we gave water like blank space is like 0, water is like number 1, right? That's kind of representing these deals. And what is the number 1? The number 1 is not really just the number 1, it's actually all binary stuff under the hood, right? So number 1 is actually, it's a byte in a computer's memory, it's actually this whole thing like this. Number 2 is kind of this thing. The point is that we've only got maybe four different kind of things. So we've got air. Let's say like air, water, sand, and rock, I think we had. So if you're familiar with binary, the way you count up is, this will be the next one. So we're only using essentially we're only using like these little last two like little binary flippy bits here. And on a computer you can only store a whole byte, right? We can't store, you have to store like 8 zeros and ones. That's like the smallest little tiny little cell of memory you've got. So we've got all of this stuff which we can use to pack other information in there, right? So one thing we could do is we could use some of these other digits, like maybe the one right on the other end, which is nowhere near what we care about, and we could do something like flag this with like a 1 if it's like changed this frame, right? So when we move that water down the first time, we don't just put a water in there, we put a water and this thing. So we can still look at these last two if you want to tell what material it is, and we can look at this first digit to kind of figure out if it's already moved, if it's already had its turn, so to speak. So that's one way to do that. There is a slight issue with that, which is that when we come back around for the next frame, all of these things will still have their 1s in them. If that makes sense. So, let's just consider, this tile, for example. So I'll kind of zoom in on just these two little tiles. So this is representing like these here. So the first time round there's water in the top one, so 0, 0, 0, 0, 0, 0, 0, 1, and there's air beneath it, which is 0, 0, 0, 0, 0, 0, 0, 0. So then what we'll do is we'll kind of move this water down, which means we'll replace this with air, replace this with water, and then we'll flag this as well, saying it's not just water, it's water that's like had its turn already this frame. And that's all well and good, but then when we come, it means when we loop around to this tile again, we're not going to touch it because this little flag's set. But the issue then is the next frame, we do want to update this water again, right? So, but when we come to it, it's still got a 1 in that, so we're going to assume it's already moved. So one thing we could do is we could go through this whole world and like clear out all of these 1s first, like reset everything to 0, which would totally work, but that's a whole nother like run through the entire world, like just to kind of reset all of those have you just moved little indicators. So a fancier, a really simple but like pretty clever approach is, what if we say next frame, the 1 means it hasn't moved, right? So that makes sense. So this will like alternate where yeah, so it will alternate between like 0 and 1, meaning that it's had its turn, which means the next time round we'll consider 1 to mean yes, this can move. So we'll look at this and say, oh yeah, this can move, and it will then get set to a 0. So next time round 0 will mean yes, this can move. So we like flip-flop between those, and it means we don't have to like clear out this little flag. This is maybe totally unnecessary. The computer wouldn't mind just like running through this whole array and then resetting all those flags. It wouldn't even mind having a whole separate like little grid which just stores these little flags and allocates a load of space to each one, but in the spirit of the old school games this is based on, where you need to use these kind of little efficiency tricks, I feel like I'm gonna do it anyway. I'm probably way overcomplicating things by doing that, but we shall see. So let's make a little toggle here. Let's say 1 means 1 means has moved already, something like that. So it's going to start off at false, no, true rather. So when we move stuff, you know, I'm kind of regretting this. I feel like I may just do it a simpler way. Let's not play with bit. Okay, let's be like. It pains me to do this, but I'm just going to do this like an incredibly basic way. If it runs too slow, this is kind of the first thing I'd reach for as like an optimization, but it's going to be okay. Okay, so then I'm going to set, when we do this move, I'm going to say set those to true, and then what I'll do is just reset all of this stuff at the beginning. And then I'm going to say if skip over stuff that's moved already. Okay, that should do what we want. It's kind of pains me how slightly inefficient this is, but honestly it's kind of not going to be an issue. Whoa. Something weird is happening here. But is that weird? Maybe that's what it should do. Let's try and figure out what's happening. Let the frame rate speed up a little bit. See that in more real time. The sand kind of spreads itself out. And then let's see how it settles here. You know, that's not too bad. So I think the reason that's happening is because if we have our block of sand that's made up of pixels, then what's happening is we'll first check this one, and it's going to then try and move first down. It can't move down. Then it's going to try and move to the bottom left. It can do that, so it starts looking like this. Delete some of this. And then we'll check this one. It can't move in any direction. This one can move like down and right, so it will do that. So that's why we're seeing this block of sand like spread out. It's because we are kind of updating it from the top down. You know, then what will happen is it will check this one. This one's already moved, so it won't move again this frame, but this one can in fact move down to its bottom left. You know, and so on, which is why this sand is like spreading out in a weird way. So there's one way we could maybe get around this, which is, what if instead of updating from the top down, we updated from the bottom up? Which may make sense in terms of like gravity. And what that will mean is essentially all of this can like no problem move. Like these will shift down one, they make a load of space, then the next row will just all get shifted down one, and it will kind of all work out like that. I wonder if there'll be any other weird effects because of that. It will mean the block falls as one, and then probably will stay as a block, and then the top will like fall out the sides. Yeah, let's see what that looks like. Maybe that's a better way to do it. So how do we do that? All we do is we switch this around, so we start at the bottom, and then we sort of count the other way around. See how this looks. Our sand is now politely falling as a unit. And it kind of spreads up. Okay, that's okay. I don't know which one I like more. This also gets around, by the way, of a lot of this thing with like the movement flags, because as we're updating, as we're going up the screen, like the stuff which is already moved it's only ever really moving down. So we never actually even check it again. So maybe we'll be able to get around this has moved thing entirely. But okay, at this point I feel like I want to be able to just draw some sand and water. So let's do something where if we move the mouse, we're going to just paint some stuff. I think processing will tell us when the mouse is dragged. Let me check that. And then mouse button, we'll kind of tell us which button. Oh, you know what? This will kind of do what we need for us. So that's up here, let's say if the mouse is pressed, say if it's the left button, then we're going to want to add some okay, first of all we need to translate the mouse coordinates into coordinates in our world, remembering that we've got this scale factor thing going on. So we should probably figure out it's just going to be the mouse x divided by scale factor, and then the y. So, you know, if this is x pixel, if the mouse is at pixel 100, but we're a scale factor of 4, then we divide it by 4, and it's actually the 25th kind of cell in the world. So we've got those positions. And I can just say, put sand down if it's the left mouse button, otherwise it's the right mouse button. I'm going to throw in some water. Let's make this ideally a bit faster. By the way, setting the frame rate is not as simple as just saying this. It will, you know, that's not how you make a game run fast. It will try to hit 30. If it can't, it will just go as fast as it can, kind of up to that. It's just the limit, really. Okay, so I should be able to add stuff. Nope, that is not happening. Why is that? Probably there's an... Oh, this is all in the comment because I didn't close that off. I should have realized from the fact part of my brain was going, oh, why isn't this coloured nicely? It should always be a hint that you haven't like closed off a comment properly. But there we go. So none of that was doing anything. Okay. We're now able to place a bit of sand. I should be able to add more of this. Can we make a little pool of water? I haven't tried the water yet, so we'll see how that interacts with the sand. It'll be kind of interesting. Okay, so straight away an issue is our water is very, very thick. It works, but what is our water doing, right? It's just sitting there in a pile. Water does not pile up in my experience. So clearly water behaves somewhat differently to sand, right? So yeah, thick. We'll just call it thick water. It's magic sand and it's thick water. We're all good. Do you remember that weird sand stuff that... What was it? Like you could move it like clay when it was in water, but then when you pulled it out, it was like totally dry sand again. I feel like that was like a 90s toy of some kind. Yeah, what was... Okay, sidetrack, tangent. Magic sand, okay. I feel like that's the stuff. Nope, that's a still frame. Hey, Color Drinker, thanks so much for the follow. What are you spamming? Oh, okay. I thought you were spamming something there, but you're not. You're contributing meaningfully. Where is this stuff? What is what is that YouTube link? Okay. Some sound experiments, interesting. Yeah, this sound stuff is kind of cool. And this was packaged into a toy. I feel like it was 90s or like a 2000s deal. Oh, like some ASMR stuff. Okay, kind of off topic if I'm honest. I don't mind you putting it in there, but if people really want to check that out, they can. Okay, let's figure out what's wrong with this water. I feel like the issue probably is that it only ever moves like down, and probably water should... Yeah, I'm not going to check this right now. It's kind of nothing to do with what we're doing, so maybe I'll check that out after the stream. Yeah, I feel like this water needs to also just try and spread out like left and right wise, so maybe we can have a little special case here. You can layer them, which is kind of cool. And again, probably the sand should fall through the water, right? Sand shouldn't float on top of water. Okay, this is getting... Okay, two things. Sand should be able to move through water, probably. And water should spread out, not just like downwards, but just like left to right. So we probably need something more fancy than this. So right now we're only moving... Okay, so to make the sand fall through the water, right now we're only ever checking if the tile is empty, then we can move into it. We've got this tile is free check. I may want to replace this with like something more like can move, where we say like depending on the substance, right? So if there's air, then we can definitely move. That's all good. If Okay. I want to check here, right? So the other substance is whatever's at the coordinate we're trying to considering moving to. If it's air, then we can always do it. If we are a bit of sand and the other substance is water, then we can also do it. Otherwise, false, right? I think that would maybe cover that. And then when we actually move, we can't just replace it with air because that would like carve a gap through the water, so we need to account for that. So it's not just going to be air, it's like whatever the other substance we're moving into is. We're kind of... So previously when something moved, it would just... So if this tile's moving down, it would just fill it with sand or whatever, and then it would just kind of delete whatever's above it by filling it with air. Which worked when stuff was just moving through air. But if this is water... If this was water, then now when we move, what we really want to do is just like swap these things around, right? If the sand is moving down, then the water needs to like move up to take its old spot. So I think this is probably the way to do things, and maybe that will... I'll change this to the substance here. So if the substance here can move down, then that's all good. If the substance here can move in other directions, okay, so already things have got more complicated where different materials behave a little bit differently. Hopefully this means that our sand can move through our water. So there's some sand, let's make some more so we can make a pool. Put some water in the middle. And then if we put a bit of sand, okay, it falls straight through, that's good. That seems reasonable to me. I've got an idea that might be kind of cool, is we could make the sand move slower. Right now it moves really quickly through the water. I wonder if we threw something in like give it only a 50-50 chance to move, which would kind of effectively give it like some water resistance or something. So if it's water and like this is a 50-50 chance essentially, then it will... This may screw things up, but I think it will cause the... like visually at least, things will look a bit more as we might expect. So fill this with our gooey water. Then if we have some sand, kind of spreads out. We did it! We did it! So, okay, still the issue now is this water piling up in a totally unrealistic way. And I think the way to handle that is probably just let it move left or right. It is currently Jello, yes. I just rename it Jello, we're all good. Okay. So let's say if it's water, then we're going to try and move left and right. Kind of similar to this, but exactly the same as this, but instead of just straight left and right, it's like... Sorry, instead of like down and left and right, it's just straight left and right. So indent all this stuff properly. So it's exactly the same thing, but just not sort of changing the y coordinate here. That may do it. This code's getting kind of long, like I could make this a bit tidier, but we shall see. There's our sand, there's more sand. Now let's hopefully see some water. Ooh. Kind of working, but something funky is happening. It's like continuously flowing, it looks like. You know what, going back to this GIF, I think it did the same kind of thing, right? It looks like it stays stable. So, okay, what I think is happening is... Oh, this kind of makes sense, right? There's not enough to like have a new whole exact layer, so the bits of water are... Yeah, so if I put exactly the right amount, then I guess it should maybe stabilize. Yeah, we'll just call it waves. We'll say it's windy and call it a day. Cool, there we go. So that kind of worked. Oh, that's weird, right? So, okay, so there's a couple of ways I think maybe to make this better. So one is if we... GG, right? We're done. Okay, so one is if we could change this so that it just prefers going left and put that thing back in. That would stop it like jiggling back and forth. It would just always roll off in one direction, which is kind of okay, like maybe not totally ideal, but it would look probably less funky. It's just, it would not be like symmetrical. So that's... Yeah, it's kind of all going one direction now, which is maybe not exactly what we want to happen. Because this does not seem right to me. Maybe also it should only flow if there's water underneath it, right? Like, so in this situation it probably shouldn't be flowing like that. So we could say if so we kind of want to check. Kind of want to put that back in as it was, where it would go either direction. But I only want to do this if it's like on top of a layer of water, so it doesn't skate across like stone, because that just seems kind of odd. So if right? So what I'm checking is only do this spreading stuff if there's water below us. Which I think will get rid of some of this jankiness. Yeah, so a lot of these simulations are kind of very easy to get up and running, but it's, I think you used the word, yeah, they're water stabilizes. That's the exact term. It's like the stability of the simulation is the technical term for this stuff. And that's very much what can cause where it gets kind of more difficult, and where this super simple logic of stuff falling and spreading out, you need to get into some actual physicsy stuff a little bit more. Okay, so it's still not stable, which honestly I'm kind of okay with, but it's more about what happens when it starts to kind of spill over. This looks okay to me, so fairly reasonable, although this stuff is still dancing around. I've got an idea for how we can maybe prevent that happening, which is that I like that it will randomly choose, yeah, I like that it will randomly choose left or right, but maybe, okay, if we wait, eventually it will settle, right? It might take a long time for this to, to finish spreading. Come on. Okay, it's going to take forever, but we can see what's going to happen, right? Is eventually it will fill this and it will stabilize. These are jiggling back and forth, which I don't like. So what I think I may do is say, once the water's like decided randomly to move left or right, it's going to try and keep going in that same direction. That way, yeah, it will not, because this makes no sense to me. But if it's like starts skating left and just continues moving that way, or randomly chooses to go right instead, that's all good. If I drop one just there, right? I'd like them to like pick a direction randomly and then just keep going that direction. So if I remember which direction they moved previously, I can... Yeah, exactly. Yeah, so that might cause things to like, you know, if I created little sand piles, it might cause stuff to bounce back and forth along the surface, but that's probably better than randomly jiggling in place, maybe. So that kind of means I need to track the momentum of each thing as well. Which I'm going to do with... we'll call it momentum. So we're piling a lot more information in here. We're getting to the point where, like, back in the day, computers may have had issues with this, but probably for now it's okay. And then what I want to do is whenever I move something, I'm going to say say the old momentum is just going to be 0. So 0 is going to mean sort of neutral, and then it will do the coin toss, and then -1 is going to mean left, and then +1 is going to mean right. So or I'm basically going to say if it's moved to the right, so if 2x is greater than from x, then momentum is 1. Else, if it's moved the other way, then its momentum is going to be -1. Otherwise, let's just kind of reset that. Maybe we can tweak this logic, but it seems like this will work. And then when we do this stuff, what I'm going to do is say so I'm going to say if our momentum at this coordinate is -1, then we are going to check left first. Otherwise, if it's +1, then we're going to check right first. Otherwise, we're going to do a random thing. 50-50 deal. Boom. That, I believe, covers what we want to do. So if our momentum is -1, then we're going to continue trying to check left. Otherwise, we're going to not do that. Otherwise, we'll randomly pick. So, let's see how this behaves. Okay, put some water in. Ooh. Looks kind of nice. It kind of jiggles around, but then it still bounces. Like, we could maybe prevent that bouncing from happening and just have it stick, but I think that may lead to like piles of water, possibly. Oh yeah, yeah, yeah. Look at that. Look at that flow to the left there. It's spreading out as water tends to do. Oh. Yeah, and I guess it's never gonna spill out of this one because it's got slightly more sand, right? In reality, that wouldn't happen. Whereas if I make the sand exactly level, it should be able to go both directions, maybe? Okay, there's definitely some jankiness going on, but... This looks better. Like, it's still... This is still weird, but it's definitely overall much better, right? It will tend to spread out and try and like maintain a level, which is pretty much what water does. Okay, next thing, I would kind of like to be able to draw with a bigger brush instead of adding little individual pixels. So let's give myself like a brush size. One. And then whenever somebody, I'm going to use the scroll wheel to change my brush size, I think. Mouse wheel. Yeah, so we do that. Do that. Down here. So if it's greater than 0, it's going to be in one direction. As we're going to reduce it, let's say if it's 0, then we don't want to go less than 1. And let's just print that out. It should appear down the bottom here. Okay, I feel like that's backwards to how I expect it to be, so let me just flip this. So scrolling up is going to increase it now, and then when I draw stuff, you need to actually do it in a bigger block. So let's add another little function here. So we're going to place a certain substance. And here we can account for the brush size. So for making sure it doesn't go off the edge here. Cover us on the x-axis. Okay, I think that will do what we want. I can just change this to place sand at so effectively just wrap this up in a little function which accounts for the size of my brush, and then underneath that line, since the place function sort of does that for us. Now more water should be easily achievable, so there's the big sand. Awesome. Oh, it's kind of cool how this stacks up and then slowly like levels itself out. It does feel very sand-like. And now fill this with water. It's fun, right? Like this is very nostalgic for me as well, from the days of like, whoa, kind of tsunamified that a little bit. Yeah, there's definitely something like I feel like this water will eventually level out. There's still some funkiness going on here, which I'm not sure I'm even going to try and tackle in this stream of like how to make this a bit more realistic. That's getting into more like actual physics. Yeah, right. That's the thing. It has to like go across like the whole layer at once, like one pixel at a time, like this. So I'm not sure what would allow us to do that. Yeah, off the top of my head, I'm not sure like what the easiest way to do that. I think it will find its level. It's it's because like these whole chunks of water can't really move. It's only like the top layer which can really do its biz. Bit more sand in here. Oh, that's cool. That's really nice, like the sand scattering there. Did that also like create a wave? That's kind of fun. Yeah, okay, this is pretty awesome. Okay, I think it would be nice to be able to place down splash effects, right? Yeah, the sound is already like super good. Like it really feels right in terms of how it all moves. This water is, yeah, it just takes a long time to even itself out. Yeah, that's really great. So I think that's because we did this thing whereby when sand is trying to move through water, there's just like a randomness to whether it can, so it will kind of get scattered in different directions and also just generally slowed down. Without that, it would have just fallen through like a solid block. This is way more, I want to say realistic, but just visually interesting. Also just super interesting to me how the sand, you place a load of stuff and then it finds its shape at the bottom. It's just very cool. So, okay. In terms of sound and water, this is almost done. I kind of, I feel like I want to do one more effect, which is, first of all, I want to be able to draw like a solid stone. So I will just tweak that slightly. So I think we can do that something like this. Middle. How can I check for the middle mouse button? Mouse button, left, right, center. Who calls it the center mouse button? That's weird to me. It's the middle mouse button, surely. Okay. Now if I can place some rock, should be able to draw deals like this. Yeah, this is pretty awesome. Yeah, so the other thing I always remember these things having is like make it push the sand. Yeah, that's hard. That's really hard because, okay, so a fundamental principle of this kind of simulation is that each little speck only ever needs to consider its immediate like neighborhood, right? Like if this bit of water is going to fall off, then it's only ever checking like immediately below and to the left and right. Whereas to push something, if you imagine trying to have this bit of sand pushed around, a bit of water is kind of going to need to know about the whole mass of this thing, right? It can't, you need to push on this side and have stuff on this side move, which basically you can't really do in this simple version of this kind of simulation. Like there's a lot you can do with this. If you ever heard of Conway's Game of Life, it's a very famous simulation of this style, which is also pretty cool, but that's one of the limitations, is that it's all local, right? Everything only cares about its little local neighborhood, and that's why it's like fairly efficient to run for however many pixels this is. 65,000 little particles on this screen. The only way this can run so easily is because each one only cares about its immediate neighborhood. Yeah. Whereas, yeah, you'd need to like think of this as a whole mass. I think Noita does some of this stuff. I'm not sure if you're around, but we showed a clip from, there's an indie game called Noita, which is based on this kind of tech. And they have like bigger chunks of objects, but that's actually way harder to do. Oop, that was satisfying. Like if you had the perfect amount of water, that was... I think there's a subreddit for that. Like it's incredibly satisfying, it all lined up and then slotted in. Now we have a perfectly even thing. Yeah. But what I always remember seeing was like oil and fire. So where the oil will like float on the water and then fire will like spread across oil. So I think that's maybe something I could hope to include in here. So mostly I want it to behave the same as water. Things can move through themselves. Cool. See you later. Let's give oil its own color. Feel like a grimy purple might work here. 160, 70, 160-ish. I think the way I'll do that is if I need more stuff that I can place. For now, let's use the middle mouse button for oil. There's our water. And let's throw some oil on top. Seems okay to me. Now I need to be able to light this stuff on fire. And the way fire works is I guess it will just spread to nearby oil and just turn it into fire. That seems reasonable. So if the substance here is fire. Then I'm just going to say they kind of spread like this. Let's have it spread in kind of all four directions. You know what, we can use the move. But probably if we didn't manage to spread in any direction, then the fire should just burn out, maybe. So here I'm going to say and then if the fire did not spread, then just let the fire burn out like that. Okay. Seems good to me. There's so many things we want to draw now, I probably need a little toggle here maybe, so when I press, for example, spacebar, I'm going to flip this around, and then if so I can have it kind of print out what it's going to add. So the first time it was sand, rock and water. Corresponding to the different keys. This is kind of a janky user interface, but kind of works for me. It'll get the job done. You know, if you're making this a finished product, you'd build a whole UI on top of this, but I'm not going to get into that. I'm just going to say oil, fire, something like this. And then when I'm placing stuff, I'm going to say the brush is toggled. It's going to be oil, otherwise sand. Middle's always going to be rock. If it's toggled, then it's going to be fire, otherwise water. Okay. Just want to make sure fire has a color. Let's just make that pretty red with a bit of yellow in there, so it's kind of orangey. Okay. More sand. Make a pool here of water. There is some oil on the top. Nope. That's wrong. Printing the wrong thing. These are backwards. Again, super janky way to do UI for this. Not really even a UI, just some obscure keyboard commands, but should work for now. So now I can toggle between, place some more sand, add some water, drop this back down, put some oil on here. If I just make fire, then oh, it moves. That's weird. That should not happen. Ah, okay, so I want to say if substance is fire, then right, so basically if it's fire, you can only move to a new tile if there's oil there. It shouldn't move either, it should spread, so how do we handle spreading? That's here, where if... In fact, what I want to do is put our fire kind of back after it moves. It's kind of janky way to do it, but I think it should be what we need. Okay, so we move the fire and then put fire back, which is effectively causing it to spread. I'm kind of hacking this in and reusing this existing function. Maybe this should be changed to... Maybe we should make like a spread function, which does this more cleanly, but this works for me. Water. Sand. Some oil. I make fire out here, it immediately gets consumed. If I do it there, it kind of burns up the oil. Okay, that kind of works for me. Not as dramatic as I would have hoped, like maybe the rules for how the fire spreads could be tweaked to be more interesting. I add a load of oil. And set a little bit of light. Ah, that's a little bit more interesting, but nothing too crazy. What about insane levels of oil? Even make some little shapes here, and then okay, yeah, this is kind of fun. You can create like a fuse kind of effect. What's that? Yeah, yeah, yeah. Right. Kind of just making a mess now, but this is actually pretty fun to play with. The other thing is when I place something, it just replaces what was there. So if I place fire down, then it just effectively deletes stuff. Okay. But you know what? This is fun. This is kind of exactly what I'd hoped to achieve. So I will probably call it a day right now. I will be, if you keep an eye out for the VODs, so on our Twitter or on our Discord, which I will link in here now. Yeah, right? Like, I actually get to go and have dinner at a reasonable time. Like, the stream was 2 hours long. Like, normally this is like a 4-hour deal, but we honestly did what I hoped. We had this little fire thing. Yeah, it was good. It was cool having you, Believe. Appreciate the raid also. Speaking of which, is anyone online who I can return the favor to? Oh, cool. Okay, so large databanks online. They're another cool kind of coding stream. I may send a little tiny raid their way. Anyone watching, you can check our Discord or our Twitter. The VOD will be posted there. That will include the full source code to this, which I will package up. Send over. Yeah, thanks so much, everyone. I will see you. Maybe not next week. I will probably be away next week, but keep an eye out again on Twitter or Discord for announcements. And take care, everyone.